So I know that this is the part that a lot of people like, which is me going over practice exams. Now at the back of the practice exam, I have a whole lot of extra problems for you guys to work on. So I think I'll give basically half the lecture over to the exam, and then we'll, so an hour and a half for the exam. It will be on paper. Now this may seem really weird, but the reason for it is that this prevents you from banging your head against a single problem because you forgot a syntax error and it won't run, right? Because then I can just simply tick off a point and let the code keep going. So the practice exam is longer and harder than the actual exam. The points roughly correspond to the difficulty of the problem. The amount of space given for a problem does not correspond to the difficulty. It corresponds to the amount of space I think you might like to use. So when you have to write code, I'm very fond of you actually having a lot of space to do so, because you might realize that you want to scratch out everything and start from scratch. You're allowed to clarify any answer you give. All questions are essay questions, including the multiple choice questions. So, in other words, if you think your answer is right, you can give me a justification for it. You're allowed to ask for clarification for any question. Things are never as complicated. I believe I threw in a hint. I know in Java I threw in a hint. I'm not sure for the Python exam whether I threw in a hint over here. Never leave a question blank. And then over here I'll put it on the actual exam. This is like the back of the first page. Over here I will put a bunch of like common functions that you might need to know, like substring and slices. So for this exam, you are allowed one sheet of paper, okay, of reference paper. Front and back, regular size, so A4 or standard Japanese size or letter size, so not too concerned with that. All right. So let's go over these. So let's refer back to the first lecture. Computer science is the study of computer. True or false? False. It is the study of algorithms. So I don't think I ever went over the term where the word algorithm came from, unfortunately, which is a shame because that's on the exam. So I should probably cover it now because it's worth 1 point. Okay, so the word algorithm is named after this guy, Algor Mitty, which is actually not his name. Because as you can see, it doesn't come up. It's actually named after Musa al-Khwarizmi. There we go. It's named after this guy, Muhammad ibn Musa al-Khwarizmi, and you might be wondering, how in the world does that name after algorithm? And why should I care about this fella, and why does he get that name? Well, he was a Persian scholar during this time, 780 to 850. Okay, they were kind of going under a bit of a golden age at that time. And he wrote a book called a book on calculation and completion by balancing. The first word of it, which you can simply condense to algebir, which is where you get algebra from. So he wrote basically the first algebra book, which worked on these newfangled numbers that were coming out of India that worked in base 10, which were fantastic for doing math in. So he wrote a treatise on how you do math with with essentially just Indian numbers, which became Arabic numbers. So so the term algebra itself comes from his book called specifically the word algebair, meaning completion or rejoining. And his name, what became Latinized, they translated it into Latin, and so his name got Latinized into Algormitty, which is where you get algorithm from. So the word algorithm is named after him. So he did a lot of fairly interesting stuff. But that's where the word algorithm comes from. So Alan Turing is often considered to be the first programmer. Yeah. False. It's actually question 3. Who is Ada Lovelace, and why is she an important figure? Because they're the first programmer, right? Turing wrote he created the mathematical model for he created the mathematical model for the computer. He's considered the father of computer science. He did the first mathematical model for the computer. He didn't build the first computer or anything like that. And the first computer that there's arguments about whether or not which was the first computer, like ENIAC might be the first considered the first computer. But different professors have different opinions, and to me, it's a bit of a blur anyway. But Ada Lovelace wrote a program for something called Babbage's computational engine, analytical engine, and she said basically we can program this machine to do other things than numerical calculations. And this page isn't worth more than a couple points, so I wouldn't worry too much about it. If you know this stuff and you did the very first assignment, you should be good. Which is, if you remember, the Hello World assignment is choose an important figure from computer science and print out 3 facts. All right, this stuff is 10 problems. The numbers are going to be the exact same. There's exactly 10 problems as well on the actual exam. The numbers in these just happen to be different. Okay? So 2 times 3 divided by 6 times 100. So remember, we're doing... remember what I said is that the math is never as hard as it appears. So now remember, PEMDAS means that for multiplication and division in the same tier, multiplication and division are in the same tier, so we do them left to right. So this is 2 times 3, that's 6. Okay, divided by 6, oh, that's 1. 6 divided by 6 is 1, right? And we're doing integer division here, right? So 2 times 3, which is 6 divided by 6, so that's 1 times 100. So that gives 1 times anything is that thing. So the answer is 100. So pretty easy math here. 1 mod 2 plus 3 mod 2. So 1 mod 2, that's the remainder after 1's been divided by 2. So 1 plus, 1 plus 3 divided by the remainder after 3 being divided by 2. So 1 plus 1 is 2, right? So this one's fairly straightforward. -1 plus -10.5. Here I'm just making sure you don't write down error, and that's actually, remember that integers get converted into floats. So we've got -11.5. Okay. Here we'll remember this is testing order of operations. So you don't do 4 plus 5 divided by. So this isn't 6 times 2. This is so it's 9 minus 6, right? Not very hard math, 3. This one, again, testing order of operations and making sure you don't freak out here, because none of these should need a calculator, right? You see this big number, but if you recognize that it's multiplied by 0, you get to say, wait, I get to ignore that, right? So you've got big number over here times 0, so the answer is 0, minus 1, so it's obviously 1.0. Negative 1.0. Sorry? Yep, keep it as a float, because integers always get upconverted into a float. Here's 2 times 4 minus 20. Again, just making sure, do you know order of operations? Which is, so this should be -12. 7 divided by 3 plus 2 times 3. So we've got a division and a multiplication. So this is what? Yep, 2. This is 6, so it gives you 8. 4 mod 2 times 3. 0. Yep. Because there's no remainder afterwards. This is 0. It's a big number divided by an even bigger number using integer division, so it's 0. This is one of my chances where I get to teach you something and you go, wait, you can do that? What does this look like? Yep, it's scientific notation. So, and scientific notation is perfectly valid in Python. In fact, in any language that does floating points. Right? So you can do scientific notation. It will not be on the exam. Just know that it exists. Okay. The following statements evaluate the following statements to true or false. Oh, come on. I thought, hold on one second. Didn't I have more nots here? Or no? Oh, I guess not. Okay. So we've got true or false. Well, it doesn't matter, right? Any true or blank equals true automatically, right? If you've got a true on one side, the entire thing's true, so we can put true here. Not true. What does that convert to? Sorry, not false converts to true. Okay? Let's see. Not. So remember, with ands, we do the left side and the right side and compare them. So not. So 4 less than 2. Is that true? Nope. It's a false statement. But the not over here flips it to a true statement. So we've got true on the left. 3 less than 10. True on the right. So the entire thing's true. Okay.
So what's true and false again?
Boolean statements.
No.
If you got true and so an and with an and, if both sides are true, the whole thing is true. With an or, it's only false if both things are false. A single thing being true for an or means the whole thing is true. Make sense? Both things have to be true for an and to work. So this one's an interesting one. 32 divided by 8 is equal to 32.0 divided by 8. So let's just do the math here. 32 divided by 8 gives you integer 4 on the left side, and you've got floating point 4.0 on the right side. I'm asking, is 4 equal to 4.0? Is that true or false? It's true, actually. This is one of those things where you want to look it up afterwards, because it turns out that basically if you've got it just goes back to something I told basically a whole week ago, or when you do any kind of operation with an int and a float, the int automatically gets converted to a float. And that's as true. So right when you do 1 plus 2.0, it becomes 1.0 plus 2.0. So just like that, the equal sign turns anything into a 1.0. And yes.
Does that mean since I think 3 turns into 3.00004?
That's only if that only happens in the rare case where I do 0.1 plus 0.2.
So if you got a number that had that long string of zeros after it.
Yep. So this is an excellent question. You're asking, is this? Yeah, false. That won't equal because of course that's the values are going to be slightly different because of rounding error. That just occurred. This happens to you have to work really hard to find a rounding error like that, by the way. And they typically happen in thirds or something like that. But it's not something you typically have to worry about.
Why did you times it by 10? Okay.
Yeah, so that I could move it up a digit. Let's see. So going back here, not true. So not something on this side and okay. So again, what we have to do for these things is that we have to work innermost to outermost. So let's look at this. Okay. So true or okay, don't care. This is true or false. This statement becomes true. So now we're looking at true and whatever the opposite of this is. So this is true or false, right? So this entire statement is true, but we're noting it, so it becomes false. So we've got a true and false.
Not true and not false.
So we've got here we've got a true and false. Okay? False because so this entire anded statement becomes false, right? And right, you work innermost to outermost, right? So now we've got that one. So now we've got not false, which is true. So again, I would you should cross this bit out and add and put true here, and then this bit out and then put false here, and then cross them both out and put false over there, and then cross that out and put true because you've got a not there. All right, so for these connect questions, you may assume that x and y already exist. Write an if statement that checks if x is a multiple of y. So a multiple means that you can, what does it mean to be a multiple of a number? Evenly divisible. So let's write an if statement that means that it's evenly divisible. And I'll use Notepad to simulate that we don't really have an IDE. So if well, we don't know what x and y are. We just know they're defined. So if x is a multiple of y, so if x modulo y equals 0. And that's all we need. Just checking if x is divisible by y. That's all I mean when I say write an if statement that does this. Okay, write an if statement that checks if either x or y is even and the other is odd. And this one's always a bit tricky to do. But basically, you have to check if one is even or the other is odd. Okay, so the if statement checks if x is even, then y is odd, or if y is even, x is odd, then y is even. So if x, so how do I check if x is even? Mod 2 equals 0, and y mod. So if x is even and y is odd, or, and we want to put these in parentheses so that we know what we're talking about. X mod 2 equals 1 and y mod 2 equals 0. Make sense? So if x is even and y is odd, or x is odd and y is even. All right, so what is the output of each of these of this code? So for I in range 10, I mod 3 is equal to 1, I n. So putting the end here means it's an optional argument that simply says, hey, instead of doing a new line, let's not put anything in between all this output. And I put a answer area right over here for you. So for I is in range 0 through 10, if I mod 3 is equal to 1. So let's go through these. So what are the values for I? Right, let's write them down on the board. What are the possible values for I? I's values are in range 10, so it is 0, 1, 2, 3, 4. There's a lot of different approaches you can use for this kind of problem. 5, 6, 7, 8, 9. So which one of these? So we're checking if mod 3 not equals 0, but equal 1. Now, if you had accidentally check for equal 0 and given an answer like, let's just print out everything that's equal to 0. So you print out 3, 6, and 9. I'd take off a point because obviously you just skipped over the problem and made a minor mistake there, right? But to get the full 4 points, you want to make sure that's 1. What I care about again is like if I can see why you've got if I see a pretty easy mistake here, right? Like an easy understandable mistake that's because of haste rather than not understanding, then I typically penalize those much less. 147. So yeah, it's 147. So right over here I can put I, and I can also put down I mod 3 over here. So 0, 1, 2, right? 0, 1, 2, and it repeats. Right? Because this number is divisible by 0. Then, sorry, I mod 3 is 1. 2 mod 3 is 2. There's no remainder left over here. The remainder is 1 over here. So it's 1, 4, 7 all together as one word. If you separate them by commas, I'm not really going to care too much. That's, again, those are minor issues there. So convert the following while loop into a for loop. One of my favorite questions is to do these kind of things. So I is equal to 2. Well, I is greater than 2. So we want to make sure, so what are i's values going to be here? Well, i's is greater than 0. So this is just going to be 2 and 1 essentially here. Just 2 and 1. So we need to do a for loop over here. that converts this. So we only really know how to do the I in range kind of deal, so that's exactly what we're going to do over here. So for I in range, so we're going to start at 2, comma, then we need to go, and then what are we going to go up to but not include? 0. And then we're going to go down by, and then we're going to go by 1s. And then what do we do in the loop? We print out an exclamation point. So it's just a matter of just figuring out what those variables in there are.
That's just going to be like 2 exclamation.
Yeah, it's just going to print out 2 exclamation points. I'm telling you, but the key here is to print out what is to convert the for loop rather than printing out what it goes on. All right, what is wrong with this loop?
It's got no counter.
It's got
Infinite.
yeah, it's infinite. It's got no, the counter does, I get what you're trying to say by saying it has no counter. It doesn't go up. It just, I is always equal to 0. I does not change. It's always true. So we've got an infinite loop there. Okay. Write a nested for loop that prints out the following: 10, 8, 6, 2, 8, 6, 4, 2, 6, 4, 2, 4, 2, 2. So what it's telling me, this is telling you to do. Okay, so remember, for the, how does this work? Well, how should we do these? The way we do these is by having a, first off, when we're doing these kind of nested for loops that are rows by rows, you know, rows and columns kind of deals, we figure out how many rows we have. So for, let's see, how many rows do we have? We have 5 rows. So for x in rows, x in range, say, yeah, so for row in range 5. We have 5 rows, okay? And then over here we need to figure out, then we need to do another nested loop for each element in that row. Okay, so let's just go with for x, yeah, or we can do item, for item in row, right? Or, sorry, for item in range, and then we got to figure out what we put in here is kind of actually the big idea. And what are we printing out? We'll be printing out whatever the value of item is. But because it's in a row, we'll need to do end, right? And then when this row is done, we'll print out an empty line, right? Right, see how I've just created an outline for it? Okay, so let's go ahead and assume that what would happen if I put a row here, right? This requires being a bit of turning your brain into the interpreter itself. So if I just put row there, wouldn't, well, it would show, well, we'd have 0 here in the first line, then I'd have 1, then 1, 2, 1, 2, 3, 1, 2, 3, 4, right? So that's not what I want. If I do row plus 1, mind you, then I'll get this in reverse. 1, 2, 3, 4, 5. And notice, what's the relationship between these values and these values over here?
Did you do it where you edit the range itself?
Yes, we're going to. I mean, that's the entire point of this problem.
Oh, and then
We're,
like 5, comma.
oh. 5, 0, negative 1.
Yeah, and then multiply by 2.
Yes. So that's so by doing it from 5, 0 to negative 1, we now flip this over to become, let's see, 5, 4, 3, 2, 1. 4, 3, 2, 1. 3, 2, 1. 2, 1. So everybody see why changing this changed that. Okay. Okay, so now, and now we can multiply item by 2. Although here, I think we don't need the row plus 1 anymore. Right, and now you said do item times 2. Now there's multiple ways to solve this problem actually. So that's just one valid solution and possibly one of the cleaner ones, but yeah. The key is to get 5 rows. And for these problems, you do have the alternate. Yes.
Isn't that counting up in the rows for item in range row?
For item in range 1, so 0. Yep, you're right. So this is 1, 2, 3, 4, 5. Sorry, this would be 0, 1, 2, 3. Yeah, so we aren't done yet. 1, 0, 1, 2, 3.
So basically, we need the thing in the first 4.
Well, we need to go in reverse here as well, right?
Yeah. Yeah, just use the same one.
Well, yep. So we can put this here, and then what do we do? Because this will be 5, 4, 3, 2, 1 in every row.
Change 5 to row.
There you go. So that will work. So the key is being able to look at the code and see what these will come out with it. And then I like doing the reverse. I prefer doing the reverse. So I will almost always have a reverse there. What is the output of this loop? Where I give you something like this. So for I in range 3, for j in range I plus 1, print I plus j, and then print. So let's go ahead and work through this one. So for I in range 3, so i's values are going to be 0, 1, and 2. J's values are on the first row is going to be 0. So on the first row, so we have 3 rows, right? We're going to have 3 rows. So in the first row, J's values are from 0 to up to and including 0. So we'll put 0 plus 0 and go on to the next line. So now we're on the second line. So I is 1. I's value is 0 and 1. So now we've got 1 plus 0 and 1 plus 1, which will be 2. Oh, and right, no spaces in between everything. Okay, and then we go on to the next line where I is 2. So what are J's values? They're 0, 1, and 2. So 2 plus 0 is, right, 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. Okay. All right. So this is the one that I'm fond of, doing stuff like this. What are the values of x, y, and z after the following statement? 7, 8, and -5. And here, I would just cross out values as you go along, right? So x is equal to x plus 1. So x is 8 now. So y is equal to 8 plus 8 minus 5, right? Not 7 plus 8, 8 plus 8 minus 5 because x updated. So that's 11. So 8, 11, and -5 plus equals 1. So we increment it so it becomes -4. Right? That's kind of a trick question over there, -4. Okay. This one is, what is the value of annoy 5342 after it's called? Oh, I didn't change this to an or statement because I copied this from the Java practice exam. So 5342. So 5 being passed in for A. So A is 5, 3, 4, 2. So if 5 is greater than 3, that's true, and 5 is less than or equal to 4, that's false, so we don't do that one. And again, in Java, it is else if as opposed to elif, so because I forgot to change that, so let me I could go ahead and change that, but So now, if 2 is greater than, so is 2 greater than 4? No, it's not. Or 2 is less than 3. That's true, so we're going to print green instead. So that's the true statement, so we print out green. So what about this one? What about 2, 3, 4, 5? 2, 3, 4, 5, right? So is 2 and 3? No, and we don't have to bother checking A is less than or equal to C, because since this side was false, we can do what's called short circuiting. And that's what your computer does too. As soon as it figures out the first part of an AND statement is false, it just says the entire thing's false. Okay, so is D is 5 greater than 4? Yes, it is. Don't even have to bother checking the other side of the OR statement because we know it's true. So that's also green. So my suggestion is try some more inputs for practice on this, because I have 2 problems that are just like that. All right. This one used to be on. So this one, it was one that used to actually be on an exam, and then I put it onto a practice exam because I like it. So here's 3 functions: foo, bar, and bos. Foo prints out foo. Bar calls foo, prints out bar, and calls bos. Bos prints out bos and calls foo. So then we call foo, bar, and bos. So what's the output? Okay. So first thing, so let's break it down in one function call at a time, right? Foo, you print out foo. Bar, okay, what do we do for bar? Bar calls foo, so we print out foo again. Bos, foo, bar, and bos. It should be fine. In C, that might be an issue. It's fine here. Bar, okay, and then we call bos. Yep, so bos prints bos and then foo again. And now bos, what does that do? Bos prints out bos and prints out foo. So let's split it up into 3 steps. Foo. So the second step's the hardest, right? Because what bar does is it calls foo, it prints out itself, it calls bos. Does it? Are you gonna check?
I'll do it later.
Let's. Well, now you've got me curious as well, because I mean, I've been assuming that it works, but right. So here, let's indent. We got to indent these things. Indent this. Indent, indent, indent. Indent here. So it works. In C, it's a problem, but not in non-Python. So now one of my what I like. What if we change bos in the following example to this? So now if we replace bos with adding a bar call underneath here, what's going to happen? So now bos has a bar call.
It's just gonna print foo, bar, and baz over and over again.
Why?
Endless loop.
Yeah, it's an endless.
Because bar calls baz and baz calls bar.
Yep. That's what's going to go on. Bar will call baz and baz will call bar. And actually, it's very interesting. Let's see what will happen here. Will it go on forever, or actually? Seems like it. So let's go ahead and Control C. Yep. It will pretty much go on forever. Let's go ahead and I'll go ahead and remove the function calls to show you what the print line statements, but it does just simply it eventually gives me an error saying that we basically went too far into recursion. Essentially, there's a certain depth that you can reach by having functions call functions. Okay. So yeah, there's a certain amount of depth that you can just hit. All right. So one of my personal favorites, and there will definitely be something along this lines on the exam. What is the output of the following code? Confundus yxz, then a bunch of code, and then we've got z. Then we've got these x, y, and z defined over here, and then I pass them in as zyx. All right. So this is one of those that's easiest if you actually start ignoring what I say. So, by which I mean basically we look at this and it's easiest if we write this on the board. So we've got, I'll just call the function con for short, right? So we've got x, y, and z, and we pass them into the function, right, in this order, z, y, x. So z is 4, okay? X is 6, and x is 6, and then y is 8, okay? And now let's just ignore these guys, okay? So we're passing in 4, 6, and 8 in that order, right? All right, and now it's got y, x, z, right? The names don't matter. It's the order that matters that it gets passed in. So for confundus, right, when we defined it, it was y, x, z, which is super confusing. So we can just do a global find and replace stuff. You can replace all those with a's if you want to, but I'm just going to pass in the, so y, so I'm just going to remind myself that y is 4, x is 6, and z is 8, because really it's these values that we care about, the 4, the 6, and the 8, right?
Just skip this problem and save it for a while.
It's really not too bad if you just remember the orders, what the orders are. If you don't, what I highly recommend doing, okay, is this. Y, z, so you've got y, x, and z, okay? Say, oh, that's silly. A, so we've got x plus is equal to 1, right? Then we've got a is equal to a minus x plus z. Print z x a. Now we go to the second one. That's a b, obviously, because that's in order. B, 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 replace z in the same way. And suddenly it becomes a lot easier to do, right? ABC, which is 4, 6, 8. So now increment b by 1 to 7. A is equal to a minus b plus c. So a minus b, so that becomes negative 3 plus 8, 5. So a becomes 5. And then print them out in reverse. 875. So by replacing the variables, so you're allowed, by scratching out the variables and replacing them with something a bit easier is better. Or you can just do, and that makes it easier, and that also helps you make sure that you keep these guys separate from these guys, right? Because global variables and local variables, they can have different names. They should actually have different names if it gets confusing. Okay, and notice that I gave you plenty of workspace on that one. It's only 5 points as opposed to some the other stuff. There's going to be plenty of coding on the exam. So here, all right, write a function called each character, which returns a new string made by separating each character with a space, with a comma and a space. So this is what we call a classic fence posting problem, which you may be familiar with which I went over in 1068, but not here because it doesn't come up as often. So notice that we've got we've got hello, and that becomes HELLO. 1, 2 becomes 1, space 2, right? Everything's separated by a space and a comma.
So turn it to a list and turn it into a string again.
Ooh, clever one. But with the list, you'd have to. I mean, that's one solution that will get you close, but it's not going to get you all the way there, right? Because right, although you can trim that example, but I like the way you think. You always go for let's see what tools I have, and then throw them at them, and that's a very valuable approach. So, because I don't want to completely shoot down what you just said, because what you said, but because the way you went there was pretty good. So, but you're saying like take our word, right? Throw it into a list, right? Split it up like that, right? And then if I turn str, well, if I do str list word, it almost gets me there, but I got a bit more than I want. Sorry, str list word. It almost gets me there, but I still got. Okay, so I can trim these off, right? Right. I could get rid of the first two characters, and then I could get rid of the last two characters, but then I'd have to deal with the quotation marks, right, in between of everything. So.
Oh, you could and then you can just do that.
Replace
colon 2.
Or,
you know what I'm saying?
I know what you're saying. You could do some interesting slicing, is what you're saying.
Yeah.
What's
the easier way?
There's probably an easy. No, I like that. That's an interesting way to do it. An easier way to do this, or a more direct way to do this is, so we've got this function called each character, and actually you shouldn't be using str. Again, this is what I get for converting something from Java. Let's call it string s. Define each string, so each character, right? And what we're going to do is that we want to print each character. And with my approach is always go for the little bits that you know are right. So we want to print out each character with a space after, with a comma space after it, right? So what we'll do is that we'll create something called an output, right, to collect them, and then we'll return it, right? So for letter in our string, right? So for each letter in here, just like we did for the count val problems, the only thing that's going on here is that we're accumulating them. We're throwing them into our output, right? Output plus equals letter, right? This would add one letter at a time into the output. Okay, so now we just need to do, and that would just print out, mind you, that would just give us hello, would give us hello, right? It wouldn't give it separated by commas at all, right? So now let's go ahead and add a comma to it and a space, right? That makes sense? So
that would add a comma and a space up there.
Yes, it would, but that's close enough. But that would be 7 out of 10 points in my opinion, right?
Okay, and then just trim to -2.
And then you, so that's one solution. Okay, I like that. You could trim to -2, right? You could trim out the last. So there's a lot of solutions to how to do that, right? But basically, once you get close to the answer, you're going, okay, now I have something close. How can I get something, right? I don't know how to do this, but I know how to get H comma Z comma space, E comma space, L comma space, L comma space, O comma space. I don't know how to get it without the comma space, but I know how to get to O comma space. And if I can get it to the O comma space, I can get it to the one without it, right? And as you said, then you could trim it, right? Everything up to the, without the last two characters, right?
Well, the second to the last character.
No, well, we would have a comma space.
Oh, okay, yeah.
So without the last two characters, right? And
Or would it be last 3 characters if you include the quote?
Let's see. No, we're not including the quote, but I think it's, let's see, -2 or -3, and I'd have to check because that's one way to do it. The other way to do it is to do this for everything but the last character. Okay, so go up to. Yeah, so go everything but the last character. I think that's everything but the last character. No, -1 is everything but the last character, right? Don't include the last character in there. And then add on that by itself. Output plus equals S -1, the last letter, right? So you do, okay, I can do all the things but the last letter, and then I can just tack on the last letter by itself.
I'm forgetting, what does return do again?
So that gives you the so that allows you to output it basically, this is the input for a function. The output is and return gives you the output of the function. It gives you something out of the function so that if I were to call it over here, each car, hello, it would give me this back, right? It would give me this back. So
You
input,
don't have to print output.
no. And most times you don't want to print something. A lot of times you don't actually want to print something.
Oh, it's
The
just
print
being
something,
safe like that, like-
yeah, well, because you might decide to pass what you get from one function into another function, and then pass that into another function, and then output that result. So not printing it means that means that you can figure out that you can. It means you decide when to print, essentially.
But we need to print this one, right?
No, it just says which returns.
Okay.
All of these will say return, unless it says print. And so let's see. Write a new function called sum of threes, n, which returns the sum of the first n positive integers that are divisible by 3. If n is less than or equal to 0, return 0. Okay, so if I give you n, this function will return the integer 18 because 3 plus 6 plus 9 is equal to 18, right? So it gives you the first 3 multiples of 3. 5 gives you 45 because the first 5 multiples of 3 are 3, 6, 9, 12, and 15, right? So see how we're adding those things together? And -1 will give you 0 because I told you if it's less than or equal to 0, return 0. So def, sum of threes. This is actually a similar thing where we're just going to have a count is equal to 0. And then at the end of this, we'll return our count. Okay. And you could probably call it sum as well. There's nothing stopping you on the exam from calling it sum. You'll just notice that sum's also the name of a built-in function. Okay. So we're counting, so if I'm given n, I'm looking for the first 3 multiples of it. So there's a couple ways to do this.
Oh, sorry.
Yeah.
Another question. So when you do return sum, does that bring it to a global?
It would only, well, I'll show you. Can I show after I write this one up? So 4x in range. 4x in range. So there's a couple ways to do this. You can go, so the first 3 multiples of 3. So we want to go from 3 to, well, we want the first 3 multiples. So we want to go from 1 to n plus 1. So, for instance, if I put in 3, this will give me 1, 2, and 3. And then I can say sum plus equals x, 3 times x. So that's one solution, where I will get, where basically, so we get, if n is 3, for instance, range will be 1, 2, and 3. And then multiplying 1, 2, and 3 by 3 gives me 3, 6, and 9. And I just sum those all together. But what's a solution where I can just use the range function to give me the numbers I want? Well, I want to start at 3, right? If that's the case. And I want to go up to n something, and I want to count by 3s, right? Because I want the first. Yeah, I could put 3 here to go by 3s. Right? So 3, then 6, then 9, then 12. So what number do I want to go up to, but not include? Close. N times, yep, 3n plus 1. So that will go up to 3. So that will go, so now if I put in 3, it will give me 3, 6, and 9. Right? If I put in 4, it will give me 3, 6, 9, and 12. And it will go up to, but not include 13. Once it goes past 13, it stops. Okay, so to answer your question about that, yeah, some number is equal to sum threes, or sum of threes. So now what this would do, this would store 3 plus 6. It would store 18 in some number. Okay? That's what return does. It would take the, what return does is that it evaluates the function into something, into what's returned. So now when this is used in expression, this evaluates to, let's see, what did I say? 18. And then if I do this, sum of threes divided by 2, this, it will evaluate to 9. So this allows, so what return does is that it replaces whatever this is with what gets returned. Okay? Just like how if you've got a function like in math, right, where we define a function, if your math teacher says you've got a function f of x is equal to x, is equal to 2x, right, in math, and then they ask you, okay, what is f of 5? What is f of 5 plus 1, right? Well, this function returns 2 times x, okay, which would be 10, and then you'd add 1 to it, right? And that's kind of exactly the way it works in Python, only it just uses different words. That make sense? And the idea behind return is that it allows you to just chain stuff together rather than having to print stuff out. Because when you print stuff out, when you print something out, if we were to print it out in sum of threes, then we couldn't use it somewhere else. So it allows you to make a bunch of, and so by having inputs and returning something, you can get a lot of you can write a bunch of mini programs, essentially, which is very nice. Let's see. So yeah, this is the last problem on here, which isn't too bad. Write a program that repeatedly asks the user to input an integer. The program keeps asking the user until the user enters the number 13. Once 13 is entered, the program outputs the sum of all the numbers entered, including the 13. And you can assume the user will follow directions. So this is what? A while loop, essentially. While the input isn't equal to 13, right? Add it to account. Right, exactly. So it's not exactly a hard problem.
And then if the user enters 13 after the sum.
Yep. So here's some more problems. The problem I will like to work on, and I had thought about giving it as a quiz, but we'll do that some other time. This is a good practice problem. So let me introduce you to 2 sites now that you can really use to practice. So codingbat.com. Okay, codingbat, so you can go into Python, and now you've actually know enough to basically do a lot of the list problems and string problems, including the ones with loops. But these will help you, and these warm-up problems have solutions, but these will, like, let's see, parrot trouble. Suppose we have a loud talking parrot. The hour parameter is the current hour in the range 0 to 23. We are in trouble if the parrot is talking before 7 or after 12. Return true if we're in trouble. So it's got 2 parameters: one, whether the parrot is talking, and what hour it is. So it's fairly straightforward stuff. Let's see. Last 2. Given a string, return the count of the number of times a substring of length 2 appears. So, and typically the examples will reveal what they're talking about. But these are great warm-ups. The other project that I like is this one over here, Project Euler. Okay. Yeah. Okay. So last couple things before I go on to this, before I completely forget them. So one problem that was not on your exam, sorry, that was not on the practice exam, but will be on the exam, I guarantee it, is a question on using a single question on using turtles to draw. Okay. So you're going to use a turtle to draw a very, 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 very basic shape. Okay? So just remember your turtle commands. Really, you don't need to know anything more than turtle forward, and then either remember that the turtle can go left or right. Yes? I mean, it won't hurt. If you forget to import turtle, I can't remember on the exam whether I tell you you can assume turtle's imported, but if you forget to import turtle, that's a minor mistake. What I care about is, do you remember how, can you actually think about like how to use turtle? Okay. This one is actually, again, it is meant to be fairly easy, and I'm gonna put some assignments up like in the next half hour on how to use turtle and with for loops and stuff. So, so the other one is Project Euler, which is all these bunch of math problems. So the first one is actually a very good one to make sure you've got to handle the language. And if you can do this in any program, in the language that in the programming language you're learning, you can consider yourself to actually have a good handle of that language. So Project Euler. If you list all the, let's list all the natural numbers below 10. So natural numbers are positive integers, right? They're the integers that are greater than 0. So if we list all the natural numbers that are below 10 that are multiples of 3 or 5, you have, so if they're multiples of 3 or 5, they are 3, 5, 6, and 9, right? So these are numbers that are either divisible by 3 or by 5, okay? You add them up, you get 23. So this problem is to find the sum of all multiples of 3 or 5 below 1,000. So that's a good practice problem because it brings everything together. It brings in together a for loop, it brings together an if statement, and it brings together a running sum. So if you want to check your answer, so the way to check your answer that your program works, create an account here, and then it will, once you create an account, a box will appear here with a CAPTCHA. You just simply put in the answer to this problem, and you can check whether or not it's right. Once you're, so here I'll go ahead, since this is an easy one, I'll go ahead and open it up using my account. Oh, go ahead. Your class is over, or it ended, so I'm sorry for holding you. Once you get it right, it actually opens up a PDF that goes over the problem, as well as a forum where people talk about their answers and talk about basically the like, here's what I did it in, like I did this in one line in eLisp. In Python, here's my solution. In in Java, here was my solution. And then some people at the beginning say, hey, here's how I did it in assembly. Like in something very close to machine code, in other words. So people try it and show off how they do it in different languages. So these problems are fairly good, and I expect that basically the first two you can probably do, the third one after some thought. Python, this 13th one is actually trivial for Python, but it's harder in other languages, which is add all these numbers together. Python, that's very easy. All right, so it is time to go, so I'll let you guys go.